we already observe, we create one deployment. Okay, we create one deployment, say dep.yaml, and we execute it. How to execute? kubectl apply -f dep.yaml. We create one service. Suppose serv.yaml, and we execute it. Service is going to create. Now one question is there. Suppose our Kubernetes cluster using 1 master and 10 worker. 1 master, 10 worker, and within this worker, suppose 5 different application is running. 5 different application 1, application 2, application 3, like this. So for each application, if I want to access a particular application, I have to create a particular service. So I am going to create service 1, service 2, service 3, service 4, service 5 for 5 applications. But question is, when I am accessing using this service, how service is going to know that I am going to show application 1? That is the relation, the mapping between your deployment or pod YAML and the service YAML. Our main target using this deployment, main target is we are going to create pod. Inside of pod, container. Inside of container, application. Right? So my question is, how this service is going to know that I have to show this application, not another application. Suppose this is application 1. So we try to know deployment or pod. 2 different type of YAML is there. We will discuss tomorrow again. That is, what is the difference between deployment and pod? What is the difference between kubectl apply and kubectl create? Okay, different options are there. So now our first target is we have to know service and our pod, that is application, or service and this deployment pod, when it is going to create, how it is going to map. Okay. So whenever we write any code, this type of YAML code, see, this is kind pod. So this type of, what are the different types of kinds are available in Kubernetes? Kind means objects. Different types of objects. Okay. So pod is the objects, deployment is the objects, service is the objects. So this type of number of objects are there. I'm going to send you the list of the objects and their purpose. Now this is kind pod and details is there. This portion is important because we have to mention the container name, inside of container the image name, because with the help of this image container is going to create, and container port number. Okay. So if you go through the details of this, see, API version v1, what is this? We already mentioned API version v1. Then kind pod, this is the object type. Okay, metadata, the name of the pod, labels, optional, used for grouping or selecting pods. So please go through this and try to understand. This portion I hope clear. This portion also clear. Now metadata. Metadata means the internal, metadata means data about data, the internal information of this pod. So please go through this and clear it. Next, what is our target? See, next one is Kubernetes pod YAML explanation. Total explained. Whenever we write any pod YAML like this way, API version v1, kind pod. So resource type, in this case it is pod. Metadata, name. See, this is one name. So unique name for the pod. So each and every line is mentioning here. Okay. This portion now you cannot understand volume or node selector, toleration, security. Okay. Few portion we are going to discuss slowly one by one we are going to add it. But the portion which is possible, like from here API version to specification. Volume, still now we didn't complete it. We are going to start volume. Volume means one external storage which is connected to pod. In our Docker container also we completed container connected to volume. So here also we are going to use volume. Mostly we are going to use EFS. Multiple container is going to connect to multiple storage, and that is basically, if I am going to continue in AWS, then it should be EFS. Fine. Now the relation between this pod and service or deployment and service. Try to understand. When I write this is my pod YAML, here I mention API version. API version, kind, metadata, specification, and this is your service. Okay, this side is service. Now in your pod YAML file I mention one labels app web. That is, I set one labels. Suppose in kitchen you are using number of container and it is not visible, still container. So we are using some labels. Okay, in this sugar, in this it is tea. Here also same, labels means nothing, just one name, just like your EC2 tag. So in this pod I use one label app web. That is my app name is web. And in your service, under specification, when you use type notepod, you have to use selector app web. So this app web and this app web, labels, selectors, this is the mapping. Due to this service is going to know, okay, I have to show these applications. The application which is running in this pod, that pod label is web, where image is Nginx and node port is 30080. So here also one graphical options. It is load balancer or node port or any other service. Here I mention number of service. Stables endpoint, cluster IP, node port, load balancer. So type node port web, and here labels web. Okay, this is the relation. So whenever you write any pod YAML or deployment YAML, you please clear your concept that how my service and this deployment or pod is related. Fine. So go through this document also. Common Kubernetes objects. See, practically one portion is over. Now we have to concentrate here. Different types of objects are there. We already use pod, service, and maybe deployment. Another one is deployment. Okay. Now, stateless and stateful. What is stateless? Container without any volume. Here it is known as PVC, persistent volume claim. Okay, we will start. Maybe tomorrow we will start this PVC, persistent volume and persistent volume claim. So, stateless means a container, a pod which is without volume. And stateful set means with volume. That is, some databases are there, some data is there. Okay, so different types of kinds are there. Pod, smallest deployable unit, contains one or more container. Yes, one or more container. Inside of pod, basically one container, inside of container one particular application. Multiple container also possible, but industry is going to use one container. We will discuss it, but just try to clear the idea. Whenever we create any container, one IP address is there. If your Docker container is clear, then you can understand it. Because in Docker container I show you how to check the IP address, inspect option is there, and how to create a new network and assign that particular IP, custom IP, to a container. Fine. So inside of pod, multiple container also possible, but you just imagine one pod is there, and inside container 1 plus container 2 plus container 3. Now each and every container they are using one IP address. Pod is not going to use any IP address. Whenever pod is going to use any container, it is accept the IP address of the container to pod. Now container is not going to use any IP address. That IP address hijacked by the pod, and pod is going to use the IP address. Now if multiple container is there and multiple IP address is there, now pod is going to use which IP address? So that
No, not port, sir. Not port.
No, node port is accessing, but pod is going to use one IP address. Node port means I am mapping from this port to this container. Okay, that is accessing only, execution purpose. But inside of pod, if I use multiple container, then pod is going to accept only from IP from one container. So that in industry, pod with single container. But other than this container, few other containers are there. That is default. That is basically default and one type of metadata. What is this? Init container, sidecar container, pause container. So we have to know in depth of container, in depth of this pod. Whenever one pod is going to create, this is your application container. But by default, this init, sidecar, pause container is going to create. So why it is going to create, when it is going to create, what is the purpose? I am going to continue tomorrow. That is in depth of container, in depth of pod. Fine. Now, so please just go through casually, not in depth, because you don't know all the services, but try to understand. We completed pod, we completed service, and we completed little bit of namespace. I show you the namespace, node. This persistent volume and persistent volume claim maybe tomorrow. Other kinds deployment we completed. Other option in future we are going to continue. I just touch this stateless and stateful. What is the meaning? Networking related also we are going to start. Right now only we are using node port increase, and nowadays increase also going to absolute because some other option is there, gateway option is there. So we will discuss it. So please go through this and try to understand these are, and we are going to complete few options. We are going to touch other options also. This is nothing but a objects, that is Kubernetes objects, which is known as kind. When we write any YAML file, we have to mention kind pod, kind service, kind deployment.
Sir, one question. So, for other containers, what happens? In real time, only one container happens as you remove this other two, three, four.
I didn't understand. In real time only one container.
Huh?
Your question is multiple container.
What about what you remove, na sir? But didn't told that what is the solution means because pod will identify only one container IP, na?
That is the
What?
industry requirement, because one application you are going to access within pod, you cannot run multiple application.
So for one application, one container.
Inside of pod one container, in one container one application. Okay,
Okay.
always industries choose this one because container has one IP address, that IP address hijacked by the pod. So multiple container means multiple IP address. So pod is going to confused which IP I am going to use. So
Right.
that application container is one. Okay,
Okay.
and number of pod is going to run. Within this pod, same application is going to run. Suppose auto scaling option is there. Okay, suppose Flipkart browsing. Flipkart browsing is running on a container, and container inside a pod. This type of, how many pods are there? Maybe 1 to 1 lakhs. Whenever it is required, it is going to scale up. Whenever it is not required, scale down. But other than this application, say browsing purpose 1 to 1 lakh, carting purpose 1 to 80,000. Because whenever we browse, we are not going to cut it. Other than this, init sidecar pause, this is important. Because interview, they are going to ask what is pod? First question. And then they are going to ask inside a pod how many containers are there. So you have to say multiple container possible, but technically one container, inside of container applications are running. Other than this, so many default container is there, init sidecar pause. And we have to discuss what is the purpose of this and when it is going to create, because it is created by Kubernetes. We are not going to create. Our container we are creating from our YAML code, but these are going to create automatically by the Kubernetes. So some purpose is there. So when it is created and why it is created, what is the purpose of this? Fine. Now if you want to create one pod and you want to access this, I show you service is required. And what are the different type of service? I discuss one service is headless. Okay, headless. Why this headless? Headless service through you can access your application which is running in container and container inside of the pod only from that node. Single node cluster. This is my master, this is my worker, in this machine only everything. So one headless service is there. You can test anything, but mostly we are not going to use it. Another one is cluster IP. Using cluster IP, you can access your application which is running inside of the pod from inside of the cluster. Suppose cluster IP using 5 node. So within this 5 node, from any node, you can access your application using cluster IP. Suppose your pod is running in node 2. You are accessing from node 3. No issue. Cluster IP is possible within this 5 node. So when I access my application which is running in pod with the help of cluster IP, it is possible from or within the cluster, not outside of the cluster. Publicly you cannot access it. Now if you want to access publicly, that is outside of the cluster, that is mostly required because my cluster is running in AWS cloud in Mumbai, but we want to access our application from anywhere of the India. Then how to access it? Then we are going to use node port. Okay, that is publicly. Publicly you can access your application which is running in pod using node port, but it is not industry standard because we are not going to use google.com colon some port number, and port number also some restriction is there, 65,000 some 575 or like this. So if node port wise we have to connect, then we have to remember each and every site wise some port number, and it is limited to 65,000. So website is not possible more than 65,000. Website or web related applications. So node port, publicly it is true, but it is only for what purpose? It is only for testing, development. We create suppose one master, two worker, and we are going to check it from outside of this cluster, but from same network. Now our main target is properly, that is industry standard publicly access. Then load balancer come to the market. Load balancer through publicly. Okay, load balancer, that is one more service. Using this load balancer we can access our application using IP address or any URL through. But this load balancer is not possible in Minikube. Load balancer purpose you have to use KubeADM or KOPS or EKS. So if we are continuing our Kubernetes cluster in AWS, AWS is going to provide load balancer. Fine. Now top level business, they are going to use 100 of different applications. 100 applications are running in multiple pod with auto scaling options. So few application running in 2 pod, few application running in 20 pod, few application running in 200 pod, no issue. We already said the scale. Now 100 application purpose, 100 load balancer are required, and 100 load balancer, they have their own IP address to URL. URL we have to inform in root 53, that is DNS, if it is inside of AWS. But suppose you are interested to continue your Kubernetes cluster in your own network, okay, using VMware. You are using physical 10 servers. Within this, logical each and every server, 10 machines are there. Inside of that, number of pods and number of applications are running. Then in local, that is on premises, where is our load balancer? So is it required to purchase one load balancer? Basically, load balancer is a device. F5 load balancer. F5 is the top level company for this load balancer and others. So this is also hardware device. F5 is going to this type of device. Okay, load balancer, this is physical device. AWS also going to use few physical device and so many logical, because inside of this some operating system, some other software code is running. Fine, this is load balancer. BGP, some protocol is there, border gateway protocol you are going to face in future. It is a part of the network. So if it is in on premises, then how load balancer is possible? Yes, for this load balancer, if it is AWS, no issue. If it is on premises, some software is there, Metal LB. Metal LB. Metal means when you purchase any computer without OS, that is just a metal. Metal LB load balancer, that is one more kind software of load balancer. So you can install it. But question is, if it is in AWS, that is rare case, but if it is in AWS and 100 app is there, we have to use 100 load balancer. For 100 load balancer purpose, we have to pay huge amount. So what is the solution? Solution is increase another software code. This is also one more service. Using increase, you can access 100 applications but only one load balancer. Okay, with the help of increase, using only one load balancer, we can access 100 applications. That is the added advantage. One more thing, when we are using cluster IP2, we are using node port. So node port is going to map to cluster IP. It is not, node port is going to replace cluster IP. By default, cluster IP is there. Load balancer, when we are using load balancer, node port is there. Internally, it is going to create some. Load balancer is mapping to node port. Increase mapping to load balancer, but one load balancer, minimize it. So we have to concentrate one by one this service, but mostly we already started node port. In future, load balancer and increase we will continue. Fine. So this is your first part, that is very basic level concept of Kubernetes. Installation on Minikube, installation using KubeADM, and just deployment, create the service and access it. Now slowly in depth of this. Okay, in depth of this. That is, we have to know what is pod, in depth of this pod, in depth of the services, because up to deployment and access is clear. Now, when I create one pod using deployment and when I create one pod using pod, two different kinds. What is the difference? When I create one pod, if pod is going to down, then who is going to create the pod, recreate the pod? Not the same pod, it is going to create one alternate, another same content pod. So that Kubernetes is known as auto healing and auto scaling. And when pod is going to down, suppose I am accessing one application from one pod and suddenly pod is going to down. So I am as a end user affected, because pod is down means I disconnected. But what happened? Before down this pod, another pod is going to create with the same application, same pod. Okay, same thing. And my connection is going to divert it to that, and this pod is going to down. So end user are not affected. So tomorrow, what is our target? In depth of pod, in depth of service. Okay, load balancer and others. Load balancer related documentation I am going to send you. If it is possible, just once go through. So tomorrow you can understand. Okay. Now we have to complete two more different types of Kubernetes cluster. One option is AWS KOPS and another option is AWS EKS. What is the difference and when we are going to use it and why we are going to use it? What are the benefits? So KOPS basically it's a tools. Okay, it's a software. It's a software, it's a tool, it's a code. It is developed by AWS. And AWS EKS, that is a service. That is a service from AWS. Using KOPS, you can create Kubernetes cluster, but KOPS is going to use kubeadm, kubelet, kubectl. Basically cluster purpose using kubeadm, because it is known as bootstrapping code for cluster. Kubeadm init. So in KOPS, using this KOPS, we can create master, worker, master and workers. You can say masters also, because whenever we create master and worker, that is Kubernetes cluster, in production we are going to create 3 master minimum, and worker, that is your choice, number of workers. Why 3 master? This is the interview questions. If your worker is 3 or 30, sometimes they are going to ask in scenario based. Suppose my worker is 30 and I am using 3 master. 3 master, high availability purpose. Now business requirement wise, we are going to extend our worker 30 to 50. So how many master is required? 324, 325, 326, like this they are going to ask. Sometimes if it is not clear, your concept is not clear, then you may think, okay, 30 worker to 3 master ratio, 1 master is to 10 worker, so maybe 50 worker, that means 5 master, but that is wrong. 3 master is enough for 3 worker or 300 worker or 3000 worker, no issues. We will discuss why this 3 master, why not 2 or 4. It should be odd number. You can use 3 or 5, but 3 master is enough, because this 3 master is going to maintain the complete cluster. Worker node only for pod applications, end user is going to connect via
So
the
maximum how much, sir, can be done?
maximum.
How much is possible by using 3 master?
There was no limit, unlimited, if your
Unlimited.
network is there. Okay, if
Oh.
you are using class B or class A, you know how many IP is possible, so that
Mm.
much worker you can create. See, Netflix is using 3 master with 5000 node, 5000 worker. Okay, around 5000, maybe 1 2 plus minus, but they
Mm.
are using around 5000 node or worker.
Okay, means 3 master is enough for daily work.
Yes, 3 master is enough.
Daily.
Now question is, uh, one Kubernetes cluster they are using 4 master and 40 worker. Okay, one junior, his suggestion is 4 master and 40 workers. So what is the problem? What is the issues are there? 4 master is not required, 3 master is enough, and either it is 3 or it is 5, not even number. It should be odd number, 3 or 5 or 7 or 9, like this. So we will discuss it interview question time why it is odd number, and 3 is enough for any number of workers. Okay, if I am going to create a Kubernetes cluster using KOPS, so it is using kube ADM, kube led, kube CTL. But if I am going to create cluster using EKS, it is completely different software which is developed by AWS. So same type of Kubernetes software in market. Kubernetes software is there. It is developed by initially Google, then it is completely open source. Now same type of software again developed by AWS, that is EKS, Elastic Kubernetes Service. KOPS is going to create master node as well as worker node. EKS is going to create only master node, and then we have to create worker and attach to EKS. When I create one Kubernetes cluster using KOPS, we have to manage master also, we have to manage worker also. It is our duty. But when we use AWS EKS, master is going to manage by AWS cloud. We are going to manage only worker node. Same as when you create one database on EC2, we have to manage everything of the database. But when we create RDS, AWS RDS, then database is going to manage by the AWS. Even you can set the backup and others, all options. It is managed by AWS. Okay. So then why KOPS? Question is why KOPS? If you check the installation steps, the Kubernetes cluster using kube ADM, then you will find it has lengthy steps and so many tricky steps also there. If you miss any 1% of these steps, then your Kubernetes installation is not going to success. So KOPS, that is a utility, one tool, one software. With the help of this KOPS, easily we can create Kubernetes cluster. But KOPS is using the same software, kubeadm, kubelet, kubectl. So basically, KOPS is going to reduce our headache. And KOPS is using only two commands. KOPS related only two commands is going to create the complete Kubernetes cluster. I am going to discuss right now this one, this KOPS in details. EKS graphically also possible, that is GUI through connect console mode, and complete your EKS creation, that is master, then create the worker and attach to it. Or command line through you can create this EKS cluster. Command line through create EKS, that is your Kubernetes master, and then create worker and attach to it. So graphically also possible through console, and command line through also possible. Okay. So KOPS, the steps and practically how it is, I am going to show you right now. When practically you are going to create the Kubernetes cluster using KOPS, one mandatory requirement is there, that is one public domain, that is one registered domain. Okay, but one more document is there, testing purpose using private domain, that is internal only. Testing purpose, development purpose, you may create it. So KOPS concept, first try to clear the KOPS concept. We are going to create one EC2. Okay, it is T2 micro, no issue. T2 micro. So in this T2 micro, we have to install some prerequisites. Okay, prerequisites. So many prerequisites are there. I am going to show you all the prerequisites. We have to confirm this. After that, KOPS related two commands. First command, this first command, when I execute the first command of KOPS, it is going to create all the configurations. Okay, as per my demand, as per my requirement. Because in this first command, I have to mention how many master, suppose master equal to 3 or master equal to 1, and what is the configuration of master machine, suppose T4, how many worker, and what is the configuration of worker, we have to mention everything. Okay. So first command is going to create one configuration as per my requirement and going to store in S3. Okay, so S3 also one requirement in your prerequisites. S3, IAM role, domain. Next command is going to execute all the configuration file from S3, and it will take 15 to 20 minutes, sometimes more than that also, to create the KOPS class, that is the Kubernetes cluster using KOPS. Once it is going to show that success, you check it. Suppose I mention one master and two worker. You just move to EC2 home, that is your default location of EC2, and you check. We started one EC2 only T2 micro. From there we execute our command, but automatically another one more EC2 is created as per our requirement as a master, and other two EC2 is created as a worker. So number of EC2 is going to show here. Then you can connect your master, you can deploy anything, that is possible. But after creation of KOPS, you must clear your account. because it is going to create high-end machine. KOPS related, you cannot create T2 micro, 1 GB 1 CPU. Because cube ADM related, when I check the prerequisites, it is going to show that minimum 2 core and minimum 2 GB or more, that is RAM. So you have to use little bit high configuration machine. First you have to check and accordingly you have to use. So once your practice is over, say within 1 hour or 1.5 hours, you can complete it. Then you must delete the EC2, you must delete the S3, you must delete some roles, and so many things is going to create. You have to clear everything. Okay. And EKS graphically also, command line also, but industry choice is command line, not graphically. You can create EKS master, that is our Kubernetes master. EKS, in our EKS, see, when I complete our Kubernetes cluster using KOPS, same command kubectl, because it is same as kubeadm. But in EKS, you can utilize kubectl. Another command is there, eksctl. Kubectl also there, because mostly we are using kubectl, and kubectl is a friendly command. But another command also there, EKS. So you can use eksctl also to check your EKS status, and inside of EKS all the informations. So right now I am going to try to show you, first discussion, then try to show you how to execute it, that is KOPS. Tomorrow we will continue EKS, and side by side theoretical portion, that is in depth of pod, service, load balancer and others. Because load balancer purpose, we have to create our own network, that is own cluster, using one master to worker node. Fine. So our next target is KOPS practically. First theoretically try to understand the documentations, and then practically we try it. Okay. I am going to stop this video right now, because sometimes video is going to crash if it is lengthy, and again I am going to start the video. Okay.